This is chapter 15, example 4, and what we have here is another adder problem, and the issue here is we're adding 4 8-bit numbers again. This time it generates a 9-bit output. And so what we want to do is to be able to tell when those 9 bits on the output is actually a correct value, because once again we add 4 8-bit values, we can technically get a 10-bit value. I think there's several different ways to do this problem. We can take it the easiest way we can think of, and certainly let's start with a black box diagram. This is first step, black box diagram. I have 4 input values that I arbitrarily named A, B, C, D. I have that 9-bit sum, and I have a valid input. We're starting with 8 bits on the input. We're going to end up with 9 bits. Let's do this. Once again, this is going to be a problem where I need multiple ripple carry adders to add this thing, but once again, the inputs are the interior of the circuit is a little bit different from the previous problems. And the valid circuit's going to be a little bit simpler. So this is the beginning of the circuit, but what I want to do here is say, I know I need to go to 9 bits on this thing. What I'm going to say here is these answers, or this first addition here is always going to be valid, because I'm going to go ahead and append that carry out onto the 8 bits, so it's always going to be a valid 9-bit number. So I'll do that for both of them. This is my little append notation, and I'm going to go ahead and put a note on that just in case CO becomes makes sense for someone looking at that, but putting a note there completely disambiguates that. Everyone knows what's going on. So these results are now going to be 9 bits. At this point, all I need to do is add these 9-bit values with the only thing I know how to add with is ripple carry adder. This is going to be a 9-bit result. The issue is if I generate a carry out, that indicates these 9 bits are not valid. And so what I need to do, essentially, here's the carry out, and I need to invert that, and that becomes the valid bit. If the carry out is 0, it gets inverted, becomes a 1, which indicates this sum is valid. Now if the carry out's a 1, if there is a carry out from this ripple carry adder here, it becomes a 0, and 0 on the valid indicates it's not valid. So this circuit, essentially, there's no choices being made in this, and they do not have any control inputs. So this circuit has no control.